read this topic before coming to answer questions, so that once we are answering these questions, the topic becomes clearer to you. So I hope you are with your writing material so you can jot down these questions for revision purposes. Remember, you must read, answer questions, and do revision. The aim is to score at least in JAM 98 in chemistry and to have maximum grade in chemistry. Any O level exam question, any O level exam you intend to write. So we are going to look at the first question but however, before we forge ahead, remember that you must subscribe. You must subscribe to actually encourage us to do this, and also give us feedback if you find this interesting, or you don't find a particular explanation that clear. Give us feedback, write, comment, tell us that, oh, I don't understand this, can you please come over or do a video on this particular question. Again, we don't mind, we are here to serve you well. You must pass that exam. So like I said, comment your remark on this platform. So we'll look at the first one, which is number one. Number one is which of the following has the least intermolecular space? Option A, we have chalk. Option B, we have water. Option C, we have carbon 4 oxide. Then option D, we have steam. All right, so one thing you should know is that in general, we have 3 common states of matter. That's very easy. That's the first thing you should know. That we have 3 common or major states of matter. We have solid, liquid, and gas. So, like I said, 3 major states of matter. Now, number 1, we have solid. So I'm not going to actually extend this. I'm going to drop some points on that solid based on the question we have on the board. So, however, as we move in this, in the course of this sequence, we are going to see other properties of matter. So, the first one for solid, you should know that solid has definite shape and definite volume. What it means is that now we can have a definite volume for what's it called, solid, and we'll actually have a definite shape for solid. Solid can take a definite shape. Solid can be, the shape can be regular or irregular. The shape can be regular when we talk about a solid can be spherical in shape, a solid can be square in shape, rectangular in shape, or different shape. However, solid also have a definite volume. Now you should also note that the particles of solid are closely packed, right? Hence, no intermolecular space, right? Yes, so this will help us actually answer this question. The next one we're going to look at now is liquid. Now, liquid has definite volume, no definite shape. Now, this is what we are trying to say. We can actually have a volume for what's it called, liquid. For example, 1 liter of water. 1 liter there is a volume of that water. We can also have 50 liters of water. So that 50 liters there is the actual volume of that water. However, the shape of water is not definite. Water can take the shape of any container it contains. Now, for example, if the container is square in shape, water will take that shape. If the container is spherical in shape, water will take that shape. If the container is irregular in shape, water will take that shape. So that's what it means when we say that liquid does not have a definite shape. Now, we should also note that um, the particles, the particles of liquid are close but not closely packed as that of solid. Hence, it has little intermolecular space. So we move to the third one, which we know. Number 3, Roman figure 3, gas, the gaseous state. Now, the gaseous state, the first point we should know is that has no definite volume, no definite shape. Now, what it means is that when we say no definite volume, for example, I have certain amount of a gas. Let that gas be CO2. I have 50 grams of CO2. If I have 60 grams of CO2 and it is released in your sitting room, the 50 grams of CO2 will occupy your sitting room. So your sitting room becomes the volume of that what? CO2. However, I can also have this 50 grams of CO2 compressed in 1 liter container. So that 1 liter container becomes the volume of the gas CO2. What it means is that the volume of a gas is the space, any space available or accessible by the particles of the gas. So the next thing we are going to look at now is the particles of gas are loosely packed. There's large space between the particles. Hence, intermolecular space is very large. So no intermolecular space for solid, little intermolecular space for liquid, large or very large intermolecular space for gas. So what I have here in that question now, which of the following has the least intermolecular space? Least intermolecular space will be seen in solid. So we look at any option there that is a solid. Now, water at room temperature is not a solid. Carbon dioxide is not a solid. Steam is not a solid. Water is liquid. Carbon dioxide is gas. Steam is water in gaseous state. The only thing that looks like a solid there is what? Is chalk. So the answer is not B. The answer is not D. The answer is not C. The answer is option A. So please, if I give you any question here, what you do, please pause, answer, and play again to see the solution of the question. So, like I said, I'm going to be giving a lot of detailed explanation. So, we move to the next question, question number 2. If you're writing, you have to pause so that you can write, then play again. So, move to the next question, which is question number 2. Now, question number 2, we have which of the following is not a characteristic of matter? Option A, matter has mass. Option B, matter cannot be destroyed. Option C, matter is not affected by gravity. Option D, matter occupies space. So if you are writing this, I'll urge you to pause the video, then write. Okay. All right. So we are going to answer this question now. Now, what I have here, number 2, which of the following is not a characteristic of matter? First of all, what's matter? Matter is anything that has mass, occupies space, and can be perceived. I repeat, matter is anything that has mass, occupies space, and can be perceived. Perception has to do with sight. Can I see this thing? Can I feel this thing? Can I smell this thing? So anything that can be seen, that can be feel or felt rather, then can be smelled is actually matter. Anything that has mass, occupies space, and can be perceived. So option A, matter has mass. That is true. Option B, matter cannot be destroyed. Is that true? The answer is yes. In any chemical process, matter can neither be created nor destroyed. Now, that is the first law of thermodynamics. From the first law of thermodynamics, which states that energy can neither be created nor destroyed, but can be transformed from one form to another. But however, you should know, according to Einstein equation, there's a relationship between energy and what? Mass. Energy is equal to mc squared. The c here stands for the velocity of light. It's a constant. So if I remove this, E is equal to m. What it means that energy is equal to mass. That means I can actually convert mass to energy or energy to mass. So if energy can neither be created or destroyed, we are also saying that matter can neither be created nor destroyed. And in a broad sense, matter contains mass. Are you seeing now? So anything that has mass is what? Matter. So if energy can neither be created nor destroyed, mass cannot be created nor what? Destroyed in a chemical process. Now the next option, C, which is matter is not affected by gravity. That is not true. Any matter rather is affected by gravity. Any matter has mass, and there is a force of gravity acting on a mass. The force of gravity acting on a mass is what we call weight. So if this is a matter and this matter has mass, there is a force of gravity acting on this mass, and this force of gravity is called weight. Weight is equals to mg. So the force of gravity acting on a mass is what we call weight. So we can't say that matter is not affected by gravity. That is not true. Matter occupies space. Is that true? Yes. So which of the following is not a characteristic of matter? Matter has mass. It is a characteristic of matter. Matter cannot be destroyed. Yes. Matter is not affected by gravity. No. Matter occupies space. Yes. Option A, option B, option D are not the answer. The answer is option C.